discontinuities, and why do they belong, those two, Phil?
Well, the two families are removable discontinuities and non-removable discontinuities. And a removable discontinuities, you can remove the point by causing the graph to have a hole. And non-removable, the graph would have either a break, an asymptote, or wiggly lines.
Ah, I see.
But Miss Benny Bob, what are the 4 types of discontinuity?
What? In a removable discontinuity, there is a point discontinuity. A point discontinuity is when the graph will have a hole, and this is what it looks like. Yeah, there's a hole up here and a point down here.
Oh, I see. So the intended height would be up here, while the actual value would be down here.
Yep.
Oh.
And also, in a non-removable discontinuity, there would be a jump discontinuity, an osculating behavior, and also an infinite discontinuity. In a jump discontinuity, the graph has a line and a hole from up. Well, this is how it goes. There would be a hole up here and a point down there, and it jumps from one point to another.
Oh, I see.
And also, in an oscillating behavior, it would look like a wiggly line. So really, this is what it looks like. It would be like going like this, and then it would be close together, really close together, so you wouldn't really have a point. In an infinite discontinuity, there would be a vertical asymptote, and there would be 2 graphs going this way and going another way this way. It can increase or decrease without bound because it would be an infinite.
Oh, I see.
It would be an infinite.
Wow, you're so smart, Miss Benny Bob.
You know, I'm tired of this. You guys can do it for yourself.
But why Miss Benny Bob?
Here, do this. All your homework. You can tell me all the answers tomorrow. Okay?
Why?
So much homework tonight.
Seriously, I have to read all these books? The freaking Hunger Games? What the hell?
What is this?
Let's do this, Hunger Games.
So what are the 4 ways to start a graph? So that's verbally, algebraically, numerically, or
And
graphically.
graphically, right?
What's verbally?
Verbally is just like how we're talking it out right now.
Using
right?
a word problem, right? What's algebraically?
Well,
Oh, you use like
numbers to solve it, right?
such as equations, f of x, or g of x. So algebraically, you use equations such as f of x or g of x. And numerically, we use order pairs or make a table, right? What's
Yeah.
graphically?
I guess that's just when you graph it, right?
Yeah, use a graph. Oh, so that's what it is. What's the next question? Oh, what's a limit?
A limit. Well, if Miss Benny Bob was correct, she said that the limit was the intended value of a graph.
You
Not
mean intended height of a function. You read limit notation.
I think that's how it was a little earlier in the chapter. Well, it says here that when the limit of f of x as x approaches 2 equals in the value.
So the limit as x approaches a number fx is equal to L. So when can a limit of a graph actually be reached?
Well, Miss Benny Bob mentioned something about continuous function. Does that have anything to do with it?
So it can only be reached when it's a continuous function? So, I mean, when you draw it, you can't lift your hand off the ground.
Yeah, and that way the intended height would be the same as the actual value. Now what is it?
Oh yeah,
Alright.
smart. What else is there? Why did Miss Beanie Bob give us so much homework?
I don't know. And well, since Darth Vader wasn't here today, I guess it's good. He should be able to help us out on our homework and possibly get even a little head start.
Alright,
Let me Facebook him. And then,
and ask for help.
where are you, Darth Vader? Okay, we got Darth Vader.
Oh, Darth Vader. Hi, Darth Vader.
Let's message him. Hey, Darth Vader. You would never guess the amount of homework Miss
Beanie Bob
gave us today. We're very lucky that today we called in sick. But anyhow, we need your help. And since you're doing the work as well, you might as well help Kathleen and I do the homework.
Right, send.
Alright, send.
Okay.
Alright. You think
Let's
that-
wait for him to reply back.
Alright. Meanwhile, I'll check Miss Beanie Bob's Edmodo, see if she might have lessened the homework.
I saw one of the problems for our homework, guys. I know how to set up a numeric table for the x values, -2, -1, 0, 1, and 2. Basically, to evaluate the limit numerically, we are trying to observe the behavior of the function as it approaches the limit we are trying to find.
Hey Darth Vader, what happened to your mask?
I lost it. Okay, to set up the numerical table, you first put in the x value, and in this case we're looking for -2. And as we travel along the x-axis, it gets closer and closer to -2. So this side would be -1.999, 1.99, and 1.9. This is getting closer to -2. This will be -2.1, and it gets closer, -2.101, and -2.001. That's for -2. From what I see that the pro of numerically evaluating limits would be that you can find the exact value, but the cons would be that you can't see the actual graph.
Well, I didn't talk about this in the homework or in class, and one of the questions on the homework, so the first, number 7 on your homework is, when can a limit of a graph actually be reached? The limit of a graph could be reached at a continuous function. The second problem on your homework, number 10, it asks, how do you evaluate a limit graphically? Well, to evaluate a limit graphically, you would have to start by putting your finger on the spot to your left and to the right of where you want to evaluate the limit. So here and here. Then how your fingers meet in the middle, which is here. If your fingers do not meet, then the limit does not exist. But from what I see, my fingers reached here, and there is a limit.
Hey, how are you doing?
I'm not doing so well. Do you think you can help explain this to me?
Oh, okay, yes,
So let me give you an example. So I'm going to draw a graph. So the value of the function and the limit of the function does not always have to be the same. As you can see from the left and right, the tangent height is at this point. but the actual value is at this point. So therefore it could exist at the same time. Okay, so the question, what is the difference between the limit and the value? So the difference between the limit and the value is that the limit is the intended height, while the value is the actual height. So basically, we draw our graph, and let's say this is our graph. There could be a hole right here, and a point here. So this would be our intended height, which is the limit, while this is the actual height at the x value of 1. So if the limit and the value were to be the same, it would be called a continuous function, and here's an example of what it looks like. And let's say we draw another line, our function, and the point was to be here. So this would have our graph have the same limit and value, since it's at one point. Our actual height would be 1, and our limit will also be at 1. And that's when the limit and the value are the same. Well, when the limit and value are different, okay, so if the limit and value were to be different, our intended height would be at 1, while our actual height, which is the actual value, would be at 2 as x approaches 2. And that's when the limit and value are different. And this would be called a point discontinuity.
So, when the limit does not exist, how are we exactly supposed to describe this? Well, we can begin over here from the right side, where there's an oscillating behavior. And whenever writing that, we'll just say this is the limit of x as the limit of c as x approaches, we'll just say it's 3. We'll say that it does not exist because there does not appear to be any intended value, or say height. And as we move on towards the left, we find an infinite discontinuity, also known as the vertical asymptote. And when writing this function, you can just say that the limit of c as x approaches, let's say, 1, does not exist due to unbounded behavior, which can be seen because this goes infinitely forward as this goes infinitely down. And finally, as we see the jump discontinuity over here on the far left, you would write that as limit of c as x approaches -2, we'll say, does not exist because, well, there are multiple things you could say here. For one thing, you can say that from the left, as f of x approaches -2 from the left, is not equal from the right. One way that you could write that down would be, it would be as the limit of c as x approaches -2 from the left does not equal the limit of c as x approaches -2 from the right. That's pretty much it.
Have you guys done your homework?
Well, Miss Benny Bob, how do you know where I live?
Don't worry about it. I bet you guys didn't do your homework. I don't even trust you guys with calculus. We're gonna do some brain exercises. Let's play ping pong. Okay, so the objective of this game is, if you guys were to lose, someone messes up, then you are the one to answer my question. You understand?
Yeah.
Yes. Okay, so the first question is, what is the substitution method.
Let us begin.
Okay, Kathleen.
The direct substitution method is a method to evaluate your limits. So basically, you take your x value and plug it into the function equation, and then that's your answer.
Okay, so my next question is, what are the 4 types of answers you can get when doing direct substitution, and what do they mean or indicate?
Miss Bidybug, if we lose, do we have to answer all 4 types of this?
Yes, all 4. Okay, Kathleen, answer the question.
So the 4 answers would be a number of 0, which would does not exist due to unbounded behavior because there's the class code. And the other one is 0 over number, which would be 0. And the other would be a ratio. If you plug it in, you get a ratio. And the last one would be 0, 0, which is
So my next question is, what is indeterminate form and what does it mean?
Okay. An indeterminate form is whenever there's 0 over 0, which cannot happen. Thus, you need to use another method in order to cancel out something that is causing the denominator to be 0.
What does it mean?
Oh, what does it mean? Indeterminate form means that you're not done yet. You're not done solving.
So when you plug in substitution and you get 0, 0, that means you need to use another method?
Yes, that's correct.
Okay. Okay, so the next question is, what is the factoring or dividing out method and when do you use it? Do this?
That was mine out.
I know.
Okay, answer.
What was the question?
What is the factoring or dividing out method and when do you use it?
The factoring and dividing out method is a method that is used after you had already attempted the substitution method, but it failed because your result was an indeterminate form, also known as 0 over 0, which the way you use it is pretty much you factor, look at the factors and see if something cancels. Once you can cancel something out, you use the substitution method again to get your limit.
Okay, my next question is, if you can't find the factors of something when trying to use the method, what else do you use? No, don't pause it. We'll just come back.
Help me out.
Go back.
I guess I lost.
The question is, if you can't find the factors of something when trying to use the factoring or dividing out method, what can you try to do?
Well, since we're trying to evaluate for the limit as x approaches a certain number, we can use that certain number. Say, let's just say it's 2. So as x approaches 2, we can only guess that the factor that is causing an indeterminate form would be x minus 2, which is also known as using the factor theorem, aka synthetic division, unit F.
What's wrong with you guys? Come on.
I'm tired, Miss Bidybug.
We don't want any more.
Well, can you answer this next question?
No.
I want a reward.
Fine, I'll answer this one, but then you guys are doing more. Okay? The question is, when do you use the rationalizing or conjugate method, and how do you know which conjugate to multiply by? Well, you only use the rationalizing and conjugate method when there is a radical in the numerator or denominator. But it doesn't mean that you will always use the rationalizing or conjugate method when there is a radical. We would first plug in the number that approaches x to the x in the column, and then solve. And if the answer turns out to be 0, 0, then that means that is an indeterminate form. That is when we know that we could use this method. And To know which conjugate to multiply by is where the radical is in the numerator method. Get it?
Yeah.
Got it?
Yeah.
Good. Now, you guys sure you guys don't want to do one more? Are you sure? What happened if the prize is cheese?
Cheese?
Yes, cheese.
Cheese.
Okay, here's the question. What are the three possibilities when evaluating limits at infinity, and what sort of asymptote is this if there's a limit at infinity?
Asymptotes. Horizontal asymptotes. Bigger on bottom, 0. Same degree ratio. Bigger on top, nada. Asymptotes. Horizontal asymptotes.
Well, you totally just answered the question.
So, Darth Vader, what sort of asymptote exists when there's a limit at infinity?
Well, it's a horizontal asymptote because the line, no matter how far it gets, it will never touch this line right here. So it will be a horizontal asymptote.
Okay, here's your cheese.
Cheese! Hey, freaking rapper. Got my cheese. Cheese! That tasted weird.
Oh, it's probably because it was next to calculus. Well, you guys know how to do calculus now, so I won't bother you again. Get out of